Alright, we're back. So, what I'm doing today, well, actually, I did a little bit of work off the stream, so nothing particularly productive, just messing around, experimenting. I built this, I changed the, I was trying to get randomness on the GPU. Pretty unsuccessfully, but I imported this noise thing and started using that instead of like super high frequency noise, using some like lower frequency Perlin type noise. And it ended up looking super cool, so I'm probably gonna see where that takes me as instead of the high frequency stuff. See, it's pretty cool looking. So that's cool. And I can like obviously limit the angles and stuff, so it'll actually like sort of look okay maybe. Anyways, but then I got sidetracked, and now I'm trying to look at Vulcan, because like ultimately I'd like this to run on a lot of platforms, and including OS X, and Vulcan is kind of, and OS X is sort of, or I guess Mac OS is what they call it now. They're sort of like phasing out OpenGL entirely. Like they stopped developing their own driver. So basically, that doesn't seem like the way to go on Mac OS anymore. So you need something that converts into metal, and it looks like that's going to be Vulcan, using some compatibility layers like Molten VK or whatever. Which, who knows how that even works, but like, basically I just don't want to be using an ancient API from the 90s anymore. Yeah. Even though it like seems to work well. If I can learn something newer with better support going forwards, might as well do that. So I was following the tutorial, and yeah, so the first difference is that rather than having GLSL text blobs, you have to give it this sort of binary format called SPIRV, SPIRV, which there's a couple compilers that turn GLSL into SPIRV. The one I'm using is GLSLC, which is I think something Google made. Jesus. Yeah, apparently something Google made, which is a little funny. But it turns GLSL into SPIRV, and I made this Bazel thing to do that automatically, which is kind of cool. It's kind of like turning a protobuf protofile into the proto CCs, proto H's using the protobuf compiler. You can get Bazel to do that for you, so you don't have to run it manually. It's the same thing with shader files. And the good part about doing this, and the good part about using GLSL, whatever the hell this is, instead of anything else is that this includes files. I don't know how well it's set up and like how smart it is about it, but that's something that is like hilariously absent from normal GLSL. But now you can do that. I'm not doing it because I don't need it just yet, but in the previous ones I did need it. But yeah, so you need to you can just do like the normal stuff like #include, and then you give it another shader. And there's a few caveats, but like in general that's like hugely required. At least like this is the first project I've done for real using GLSL, and like I ran into this requirement like instantly. Like I was like, well shit, I've got these functions that I need from multiple files, and I'm literally just gonna have to copy and paste them or do some even more heinous stuff. So I'm really happy this is included here. Okay, so basically I followed the tutorial, I made my hello triangle, and I turned it into a hello quad using a subsequent lesson. Bazel run Vulcan. Also switched to GLFW for this thing instead of SDL. I don't really know why. I don't think there's a good reason, but the tutorial uses GLFW, so that's what I'm gonna go with. But yeah, just to draw a nice little quad like that takes over 1,200 lines, so that's cool. Okay, so now the trick is going to be to figure out how to represent everything I've already done in Vulcan instead of OpenGL. So that means redoing basically all of game controller.cc, all of these things. All of this is gonna like triple in size to actually work in Vulcan, because Vulcan is so much more verbose. And then all of GL emitter and stuff. Hopefully the shader code will actually not change a whole lot. It will have to change a bit because push constants are different from uniforms, I guess. I don't know what push constant is, but apparently uniforms are gone. So now you have to use either a uniform buffer object or a push constant. And I think a push constant is basically what a uniform used to be. Push constant versus VS uniform. So I should figure out how to use a push constant real quick. Let's look at what this guy has to say. Big takeaway here is that mapping memory is a really slow process, so if you need something mapped, keep it that way for as long as you can. This is likely not news to anyone except me. You should totally use push constants when you can. Why wouldn't you do it to packing multiple objects worth of data into a single buffer versus giving every object its own? Pension files, big winner, are great for data that updates frequently. So I do have some data that updates frequently. So let's look at my shaders real quick. So these are where I'm going to be heading, but these are only work with OpenGL for now, but I gotta convert them to Vulcan. So I have the main one is the emitter. And so this has start index is updated every time, although theoretically, yeah, start index is updated every time. Although theoretically it could just be, we could just pass it num emitted and it would do the modulus operator internally. But to keep it simple, let's just say both of these are updated every time. But then the rest of these ones are, well, this one is also updated every time. These two are static. These two are static. These two are updated every time. And there's a few others that are updated every time. So basically, there's only a couple of them are static, and the majority of them are updated every time. So basically, the emitter is really going to want to use these push constant things. Push constants are great for data that updates this frequently because you don't actually need to allocate buffers for it. This also means that we need to do a few things differently from the previous four approaches we looked at, like changing how we declare our uniform data struct in GLSL. Okay, so let's see if I can use push constants with just to learn how push constants work. See if I can come up with something to do here. So there's not a whole lot going on in here. I guess I can change. Why is that a vec4? Why is position a vec4? What am I missing here? That is strange. Position member is now put in homogeneous vertex. Oh, homogeneous. Does that mean it projects it into a higher dimensionality? W is the fourth coordinate of the three-dimensional vector. It's normalized 2. Okay. Alright. Right. That's so you can rotate in the stuff with the transformation matrix, which is 4x4. That makes sense. Okay. Cool. So, as a Z position, frag color, let's just change the color with the push constant somewhere. Constant uniform color, okay. So this is change. And we want a vec for color, I guess. Does he have the shader code in the CPP here? Damn. Well, what shaders is he loading? Oh, here we go. Shaders, push constants.